Imagine you're sitting in a lecture hall, and the instructor asks the class to break into small groups for a discussion. You reluctantly adjust your seat to face the others in your group and start to engage in a discussion. As the other groups around you start to do the same, it starts becoming noisier and harder to hear others in your own group over the sound of other groups. In such a situation, you might move a little closer, orient yourself a little better, or just pay real close attention to better hear and understand others in your group. What you're doing in this situation is called auditory stream segregation. It's the process by which your brain can separate the sounds in your environment into different streams so that you can pay attention to the one that's of most interest to you. This incredible ability that your brain possesses develops gradually from birth and isn't fully mature until you're an adult. So now imagine if you were an 8-year-old in a primary school classroom trying to pay attention to your teacher while ignoring the chatter of other kids. That would be a lot harder. In fact, previous research has shown that children are, quote, broad listeners who particularly struggle with narrowing their attention to a single stream of sound. But it isn't fully clear why this is the case, and that's why I'm studying this topic. I want to add to our understanding of children's developing auditory perception. So how do I do this? As much as I would love to take my research into the classroom and study kids in their naturalistic environment, that would introduce too many variables outside my control. So instead, I'll have them come into my lab where I seat them inside a sound-treated room, simulate an auditory scene like a classroom using loudspeakers, and have them perform a task. This task could involve listening to short sentences of speech in the presence of background noise and repeat what you heard. I would then score the number of words the child understood correctly. I could also simulate other conditions, like perhaps hearing loss, and see how that affects performance. And by conducting this experiment in children across a wide age range, I can map out the developmental trajectory of this important ability. This line of research has several important applications. For instance, it can help us design better tests to diagnose children who may experience more difficulty than others with paying attention in a classroom. And often a simple test of hearing is insufficient to measure complex skills like auditory stream segregation. Furthermore, a better understanding of children's auditory development can help improve the design of hearing aids so that children with hearing loss can hear better. Ultimately, the goal of this research is to make the classroom learning experience more accessible to all children.